In this video, I'll teach you how to build inventory systems in Ren'py, starting from something simple to something a bit more complicated. At the end, I'll even give you some example code, and hey,
Give me the code!
don't skip right to the code just yet, because we need to talk about some fundamentals that are going to be increasingly relevant as things get more complex. So to start, an inventory system is really just a way to take a bunch of items and bundle them together in a group. You can have a one item inventory, you can have an inventory of the same item, you can have an inventory of different items, multiples of each of these types of inventories, and items don't even have to be things. Well, let's take another step back, because we still need to discuss what an item is and what we need from an inventory system. Like most things in games, an item is a variable or group of variables that represent a player possessing something. For an item, we need to consider how the player will obtain it, hold it, use it, and lose it. Not every item needs to directly address all these things, but it's worth considering. For the inventory system, it's more about figuring out how you want the player to interact with, see, and consider the items they've collected, and most games will have multiple different inventory systems for distinct groups of items. For instance, in my game King of the Cul-de-sac, I have the player in a loop. They collect quarters to spend at a gacha machine, and they spend the quarters to get toys. If they get the toy they need, they'll advance, and if not, they need to collect more quarters, then go back to the machine. Something like this can be made of three very simple intertwined inventory systems. We have an inventory of quarters, an inventory of figurines the machine has, and the inventory the player has. The player's inventory in this scenario is the easiest. In this particular narrative, the character doesn't actually care about all the figurines they collect, they just care about one. So the inventory for the character is only ever figurine equals true or false. Quick aside, when you make a binary variable like this, you spell true or false with a capital T or F, otherwise Ren'py thinks you're referring to a different variable you did not create. For the money though, it's only slightly less complicated because it's only one item and we just need to keep track of how many of that item they have. So we have the player obtain money through a few different simple mini games. Hold it on the way back to the gacha machine, and then use it and lose it in the gacha machine. In this case, I want the player to know how much money they have at any given time, so I have money total displayed at all times. For this, we're going to create a variable money and set it to 0 by default. Each time they collect a quarter in a minigame, we'll increase the number money by 0.25 with $money plus equals 0.25. For the display, super simple. We have a screen overlaid on top that just has a text box in a frame that displays the variable money. Referring to that variable replaces that text in the brackets with the variable showing there, so every time the variable changes, the text changes. Once they spend each quarter, we subtract that money with $money minus equals 0.25. Once it hits 0, we don't let them spend it for another pull, so we never need to worry about it. By default, if you're doing a store in your game, you'll want to make sure that it tests to see if money is greater or equal to the price of the item you want to buy, and if not, it doesn't let them spend the money. And if there's another way to lose money, you'll want to have it checked to make sure it doesn't take more money than what your character has. The final inventory in this system is the collection of toys in the machine, and this one's pretty interesting because it's different from a typical player's inventory. In this case, we want to start with a full inventory and randomly remove items over time. So to make this inventory, I made a list. I set a variable machine to be equals to this list in brackets. Toy 1, toy 2, toy 3, blah, 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 figurine. Now, if I wanted to make this purely random, I could use the ren'py.random.choice and select machine there in the parentheses. So this is going to take one of these random list items from machine 1 and make that equal to the variable here. So I could use that variable to call out that toy in the dialogue. But I want the player to be more likely to finish over time. So every time one of these is chosen, I'll remove that item from the list. $machine.remove, and in parentheses variable, and I'll remove that item from the list. I have duplicates in this list, so the machine.remove variable code will only remove one instance of whatever random item was chosen. In my original game, for every one of these different items, I had different if-else statements that would show a different image based on what toy was chosen. But nowadays, I use class objects in Ren'py a lot, and that can take this big list of dialogue else if statements and simplify it down. I went over class objects in my RPG fight video, like really briefly, didn't get too deep into it, but I'll go over this again real quick. A class defines a kind of variable that's made of multiple variables, and a class object is an instance of that class where all those variables are defined. So the class defines the size and shape of a container, and the class object defines what fills one of those produced containers. In this case, I want to make a class, toy, that's made of a name and an image. Under initialize Python, which means we're creating this class right when the game opens, so when in Python initializes. I'll list out class, and then the name of that class that I want, toy, colon, and then under that we're going to define, and under initialization, I don't know why that init is there, but apparently it's important.
Oh, I Googled it.
In parentheses, we'll put down self, name, and image. In parentheses, commas in between. That's just going to set the format for how we are going to define the class later on. Underneath, under self.name equals name and self.image equals image, that really just sets what those individual attributes are going to be called. In my list now, instead of just these names, I'll make class objects that contain these names plus an image. So instead of just toy1, we'll have toy because that's the class, parentheses, we'll have the name, which is toy1, and the image, which is also named toy1. That's going to be the name of the image. Each of these items in a list now contain 2 variables each. Ren'py lists are kept in order, starting from 0. If I wanted to select the first entry in a list, for example, I could say list underscore name, and in these little brackets there is 0, and that variable is equivalent to the first entry in that list. So instead of randomly selecting an item, I'm going to select a random number from 0 to the maximum entry in this list. So I'll set a variable, rand underscore number, with ren'py.randint, and set the low bound to 0 and the high bound to len, and in parentheses, machine -1. This len function determines the total number of entries in the list, but because the actual reference number starts with 0, not 1, we'll want to subtract 1 from that number to set the highest number this variable can choose. Basically, if there's one item in this list, len in parentheses machine is going to tell us the number is 1, but the number we want to reference that number of the list is 0, so it's always going to be 1 below. Since these are each class objects, though, we can select the class object's name by saying in brackets, machine, bracket 0 dot name. Instead of this long list of else if statements, we'll use the function ren'py.show, and in parentheses, the class attribute for that list item, and then comma and @list equals in brackets, with a transform in these brackets, in this case, true center. That way we can place the image with this tag. When we want to hide the image, we'll use ren'py.hide and then the same text there. So now that we've covered a few ways to handle the items themselves, let's talk about how to show them in an inventory. So the simplest is just to not show the inventory at all. Have a list, name it something like inventory equals and then empty brackets. To add an item in the list, use this setup. $, followed by the name of your inventory list, and then in parentheses, add the item name in quotations. So $, list name, .append, and in parentheses and in quotations, item name. You can get away with not showing an inventory if you have inventory items align with big narrative events. You might not remember picking up a random flower from the ground, but you'd probably remember if you received a rose from the prince at the big ball. When you hit the point in the story where it's important that the character has something or doesn't, we can evaluate if it's in the list. To see if a player has an item or not in a list, you can use this if statement. If item name in list name. Item name obviously being the name of an item, in quotations usually, and the list name is, your list name. But if you want to check the opposite, that the player doesn't have an item, you can use this style of if statement. If item name not in list name. If an item gets used up or left behind, use $ list name dot remove and then, item name in there, again, to remove that item from your inventory. Now, admittedly, some players may still need a reminder of what they did or did not do in a playthrough. So if you wanted to list these items out in a separate screen, you can make a screen like this, where in a VP grid, you put down for I in list name and show text for brackets I, making sure that's in brackets, and now it should show the name of each of the key items that are contained in the inventory list whenever you need it. And another quick little note, you may have noticed the N kind of got cut off in ribbon there. I love using VP Grid, but one of the weird quirks about it is that the first item in a list is considered the parent of the list and everything else is the child, and the parent's setting the width and the children are going to be equal to that width. So you'll notice that once ribbon became the top line there, nothing on metal got cut off. The easiest workaround for this is just making sure that whenever you use a VP grid, you put things either within a frame or you put it in a button that's large enough for all the information you need. So for my code here, I just put the text inside of a frame with an X size of 200 that just made sure that there was at least 200 pixels of width whenever a new item got placed there. But sometimes you'll have items that you want the character to have on hand that they can just use at any time. And for that, we can use utility slots. I don't know why I called them utility slots, like it's some industry term. It's not, it's something I just made up. It's a different kind of inventory system. That's all it is. So we'll make a new class and we'll only worry about two attributes for now, the name and quantity. By default, we'll set the quantity to 0. For now, we'll only worry about two types of items, a healing potion and a mana potion, but only one of these will be usable for now, the healing potion. The healing potion by default will start with a quantity of 0, but for the mana potion, you can override the default quantity by setting it to 1 here. As you can see, when you create a class object, you don't need to declare each of these class attributes every time. For the healing potion, it's defaulting to the quantity that we set here, but if we didn't define it, then the healing potion just wouldn't have the attribute quantity. Class attributes get defined in order here, so if we had a third attribute, power, and added it third, we wouldn't be able to define it without first defining the quantity. So when you set up class objects, the order of these attributes matters. I put the essential stuff first, optional stuff in the middle, and at the end, I'll place any attributes that will be constant for any of these class objects, and any attributes where I'll want to set the value for them later on. Now let's make a quick and dirty HP bar, which we'll set so the maximum HP is 100, and the current HP to be 50, and set those variables in a screen with this bar thing here. I'm not going to go into really big detail because this is an inventory video, but you know, this is cool. This is a cool little thing I'd like to make a lot. Actually, is HP a kind of inventory item? Let's say yes, so I'll explain the bar real quick. Okay, so in this screen HP bar, we have a frame. The align is just going to set it so the X alignment is right in the center of the screen, and the 0.0 for the Y alignment is going to set it at the top. And we're going to set it for X size 500. That just keeps the frame only 500 pixels wide. Otherwise, this bar could just take the whole width of the screen. For the bar, we're going to set the value. And the value is the thing that's going to be changing the actual width of the bar from the left side. And the type of value we want to use here is animated value, because that does a cool little animation whenever the HP like goes up or down. And you set those attributes for animated value here. So we have HP, which is going to be the active value that is being changed, max HP, which is going to be the highest value there. So the maximum value, and 0.5 just determines how many seconds, in this case half a second, it's going to take to animate from the current value to the next value that it changes to. So a few different ways to make bars, but this is my favorite. I don't think I use too many others. Okay, now that we've made HP, we'll make a button for the healing potion that will manipulate the HP. So we'll make a separate screen, utility belt, and add 2 text buttons. The mana potion won't do anything for now other than show the quantity using utility items in brackets 1.quantity, but for the health potion we'll show the quantity plus give it 2 actions it does when pressed. First, using set variable, we'll set the variable to set to HP and make it set the variable as HP plus 20. This just adds 20 to the HP variable. Then we want the health potion to be used up, so we'll change the value of the quantity attribute. For that, since we're manipulating a variable within a list, we're going to use set field to select the field, the variable we're changing in that field, and then the new value of that variable, which is utility items 0.quantity minus 1. In the actual game, we'll show the utility screen we made as well as the HP bar, and while HP is greater than 0, we'll increase the quantity of healing potions, which you'll see updates the value in the screen, and then we'll have the HP decreased by anywhere between 1 to 20 HP and loop that. If we want to stay alive, we'll tap on the healing potion button, which increases our HP, but if our HP ever goes to 0, we get you died. Okay, but what if we want a large inventory of usable items? And while we're at it, I don't want to manually create every single one of these items by hand. Am I just made out of time? How about if we make the game actually create new items for us? For that, let's keep our HP bar, but let's change our items. We'll create a new item class and give 3 attributes: name, effect, and effect value. Then we'll create some lists. First, we'll create some pre-made random items, a healing potion and a greater healing potion. Next, we'll create the building blocks for some randomized items. We'll make a list of colors. So we have the, yellow, red, orange here, and then these 3 effects. For our backpack itself, we'll use a VP grid, so we can fill this up with a lot of items with 2 columns and up to 30 rows. If we exceed 60 items, our game will break since we set the maximum size of that VP grid. So in our game, we'll make sure that in this while statement, we only keep it going while our number of items are below 60. And if we exceed it, it says they filled up their inventory. Otherwise, you just want to make sure that whenever a player adds an item to a list, they're checking to make sure it doesn't hit that max value we set. And I just kind of chose 60 items because that just seems like a lot to me. You can also just remove this rows section and it'll just kind of keep this going forever. But who wants a forever group of inventory items? Inside of this VP grid, we'll say 4 item in backpack, which means for every list item in the backpack, we'll display whatever is below. So in that, we'll create a frame, and because each of these instances will refer to the specific item that's being called, we don't have to worry about list names like we have before. Instead, you can use whatever term we want to refer to a list item and add .class attribute to the end. Usually you'll see example code referred to for I in list name, but I like to be more specific. We'll create some if-else statements here. So if the item effect is heal, we'll make a text button that uses the item name. And then for the action, we'll use set variable to adjust the HP dependent on the item.effect_value. And then once it's used up, we'll use remove from set to designate the backpack and then the item being removed, this one. As a reminder, we're using set variable because we're changing a global variable. We're using remove from set because we're removing a whole object from a list. But if we were manipulating a variable within a list, we'd use set field like we used before. Anyway, then for damage, we'll do mostly the same stuff except this. We'll be subtracting the item effect from the HP, and then if it's anything other than heal or damage, it'll do nothing other than remove itself from the set. But you can make it do whatever other action you want, obviously. So that's what all the objects can do, but let's go into the actual creation of items, which I think it's fun. And I'm always trying to come up with new excuses to just have games make random items for me. Back in our game, we'll pick a random number, 0, 1, or 2. If it's less than or equal to 1, we'll add rand_items and in brackets D3 to the backpack, which again, that number will be only 0 or 1, our healing potion or greater healing potion. If we pick 2, we'll get a bit more complicated. So if we pick 2, we're going to add another backpack item, but you might notice all these class attributes here are variables. Whatever those variables are, those are what will be added to the backpack. So let's look at what those variables are. We're going to randomly pick a number between 1 and 20. Pick a random effect from our list, and then pick a random color from our colors list. But once we do, we'll remove them from the rand colors list, so we'll never have 2 different potions with the same color. Once we have that set, we're going to add the same class object to both the rand items list and the backpack list. So if we get D20 to be equal to 17, random effect to be damage, and color to be yellow potion, we're actually saving item yellow potion damage 17 to both of these lists. And each time we run this section, we should be getting new random combinations. Once we get all 6 random colors filled out, we won't be able to use this section again. And instead, if the user rolls a 2, it will select a potion randomly from list slots 2 to 7. And each time we get one of those randomized potions, it should be the same as the first time. So if we pull yellow potion again, it should have all the same effects. Okay, so we're going to keep getting some new items. And red, blue, yellow. Okay, so we have a few of the same ones here. So we have one blue potion and another blue potion. Let's see what that does. So blue potion increases the health. Blue potion here should also increase the health, which it does that, and should be by the same amount. Same thing with yellow potion here. So yellow potion also increases health, by the same amount. Okay, now let's say we're crazy And we want a list of inventory items that we can go ahead and drag and drop on one another to combine them into new items. This sort of thing is common in adventure games where you might combine two items to solve a puzzle. So for our example, let's work around the limited inventory space of old adventure games. First, let's create our inventory list with a set of 4. A right half of an amulet, a left half of an amulet, a book, and a locket. We'll want an inventory screen that can combine the two halves of the amulet together to make a full amulet, and combine the book and locket to create the grimoire. In our game, we won't be able to pass by this while statement until it's in the inventory, and then we won't be able to pass this while statement until we have the grimoire in our inventory. So in this screen here, we'll create 4 drag items at different locations, which we're going to treat like inventory slots. Each of these slots will only be shown if the total length of the inventory is long enough, and the drag names and text will be based on the corresponding list item. So slot 1 will have the index 0 number on the list, slot 2 will have index 1, and so on. We'll set each for draggable and droppable to be true, since we want to be able to move and combine these in any order, so any of them should be droppable and any of them should be draggable. Finally, we'll make a function for when an item is dragged, which we'll do under initialize Python here. A defined function is another way to do some operations in your game in its own little isolated section. So let's create a simple function, +1. For +1, we'll take a number, which for the sake of this function is called num, but it will really be whatever number or variable we want to put there. Then we'll add 1 to that number. Now, unless we say return and then give the variable or a command there, this num +1 number will only ever be used inside of this function. For instance, we could also say second number equals 4, but we won't return that. When we run this function in our game, it'll add 1 to the number we set, but it won't change the second number. There are a few other things we can do with functions like this, like you can see here we can append an item to a list, but I'll just get into the things relevant for combine check here. For this defined function, we'll call it combine_check, and we want the drags and drops involved in this operation, so we'll include those in the parentheses. From what I understand, when you move a drag object around the screen, it returns back the name of the drag item you dragged, plus any droppable you dragged it onto, saved as a tuple here, and we're naming these drag and drop for ease of use. I don't know exactly why, but you need to refer to the drag like you're referring to the first element in a list, so drag in bracket 0 is how that'll be referred to in the code. If I'm misunderstanding this completely, feel free to yell at me in the comments, but please be gentle. Now that we have that together, let's look at what this function will do. Normally, when you have a drag object, you can move it anywhere around the screen and drop it wherever you want. But in this case, we don't want an item to leave the slot it's in unless it's being combined. So we want the inventory item to snap back into the slot position. So if we don't get a value for a drop, which we say with if not drop here, we want to figure out which slot position that object should go to, which we'll check by running against the inventory name. So if the name is the same as what's in the inventory list, item 0, we know it goes in the first slot, etc. Then we'll use drag snap and put down these coordinates as a tuple. That moves the drag item back to this position. Then we'll return back to the screen. Next, we want to check to see if the items combine. So we'll check to see if right half of an amulet is dragged onto the left half of an amulet by checking drag0.dragName equals right half of an amulet and drop.dragName equals left half of an amulet. Making sure you use those double equal signs there. That's how we check if that's it or not. And then we want to check vice versa. So we'll add an or statement and make sure that both of these statements that have the ands together are in parentheses, since we want these ands to be true together. Once we do that, we'll remove the right half and left halves from the inventory and add in the full amulet. And then return true is the equivalent of tapping the dialog forward in Ren'py after it returns, so I do that to force Ren'py to evaluate to the next dialog. Now, as you can see, this is causing something funky to happen, but I'm not going to worry about what exactly is going wrong because I can just hide and show the screen again, and 99% of the time that'll fix your problem. We'll do the same thing with the book and locket as an else if. Then, to make sure the inventory items can't be dragged to a slot where they can't combine, we'll add the same snap code from above and add it as an else statement below. Now, all right, you might be noticing we don't actually need the drop stuff at the top because it's kind of being covered in this else statement, and as long as these two conditions aren't being met, it should always do this one, but I really wanted to show you that drop thing, so we're keeping that in there. And now that that's built, let's see it in action. All right, so we'll merge the left half of an amulet onto the right half. Bam, everything moves around there. It says we got the full amulet, but now I need the grimoire to continue. You'll notice when I move the full amulet off of there, it's always going to snap back into place. If I try to move it over the locket or the book, it's going to snap back into place. So that's working well. And even just trying to put stuff on the empty slot, that's not going to work. It's going to snap back in. The only thing that's going to work is move that book onto the locket, which makes the grimoire, and now we're all set. We did it. Great job. Now, obviously, the inventory doesn't have to just be 4 slots long. You can make it as long or short as you want. You can put it in a VP grid. You can add the 4i and whatever and just make it super long. Whatever, it should all be fine, but the basics should work for everyone. In fact, I'm attaching a link to all the code I've been showing you below so you can mess around with it yourself. You can just copy and paste whatever code you need. Just keep in mind the parts of the images won't work unless you have images with the same names, but otherwise these things all work, right out of the box. But along with this code, let me give you a warning. Don't let this get too complicated. You can really overcomplicate this. This can get gross. Inventory systems and manipulatable items are a mainstay of most games, so it's easy to say, oh, I want an inventory system that does X, Y, and Z. But sometimes it's hard to tell that what you think is a unified inventory system is actually several systems working in tandem, each of them with their own individual quirks. So usable items will often handle differently from equipment, which operates differently from key items or quest items, and all those run differently from money or hit points. For instance, let's look at that drag and drop inventory screen. You might have noticed that if you have 2 objects with the same name, it's not going to work quite right because it's evaluating each of the list items in order. So if you have book in list positions 0, 2, and 3, and then when you try to drag books in positions 2 or 3, it'll get snapped into the position for inventory slot 0. Now, a way around that is to create unique identifiers for each item. So you'll want to create a variable that can go up by 1 every time you get a new particular item. And then when you add that to the list, you'll create that name by putting the item name down, plus the number expressed at the end as a string at the end by using plus str, and then parentheses the variable name test. And then when you check to see when that item is used, you're going to add in brackets, colon, and then the number of characters before the number starts. So in the case of the book, in brackets, colon 4. But now you need to make sure there's no items that start with the word book, or else you're going to run into the same problem anyway. So maybe the solution isn't to modify this item screen, but to reapproach how you handle these types of items to begin with. Maybe get inspirations from crafting systems, or only allow a few key items to be combinable in this way. If you want to know more stuff you can do with your inventory screens, check out my screens tutorial right here. And if you just want to watch another video and hang out sometime or something, you can watch this video here. I'm a pretty good hang. My joking banter is just, well,